In this video, we are going to use Coulomb law to calculate the electric force between the charge, and this is the problem we are going to try to answer. The question we are going to try to answer determine the magnitude and the direction of the electric force of the proton and on the electron in hydrogen atom. So, as you know, in hydrogen atom, you have one proton. In the nucleus, you have one electron going around that nucleus. So it is always good to draw a picture of the situation so you can get that out of picture, and then we can draw a little represent the distance between the going to need to use all information, the charge and the distance to calculate the electric force. Now, before we actually calculate the magnitude of the electric force, we can already determine the direction of the electric force. It is said in problem of the proton on the electron, the force of the proton on the electron. So we want to know what force the proton is applying to the electron, so we are going to draw the force on that electron. And the force on the electron is going to be to the left or in the negative direction. So now we know the direction of the force already now, because these are obviously absolutely charged. Practically now I don't really care much the arrow, because we are really use the represent absolute magnitude by just draw arrow, so I know the direction of the force. Now we are going to calculate the magnitude of the force, and we are going to do that using Coulomb's law at k q1 times q2 divided by the square of the distance between them. Now I would have put q1 and q2, but instance, I know it is an electron or proton, but QE and QP, that why that like to know, we need to know charge of electron. Well, you can just look that up by, we are also going to know that K is the 9 times and the 9 Newton meter squared. Now we can look up the charge on the electron. The charge on the electron is 1.6 times 10 to the minus 19 coulombs. The charge on the proton is the same on the point 6 times 10 to the minus 19 coulomb. Now, obviously, an electron has negative charge and proton has a positive charge. But in this case, we are just going to use the magnitude of the charge, and I will tell you why in your moment. Okay, now we also need to know the distance from the proton electron. The average distance in hydrogen atom is 0.53 times 10 to the minus 10 meter. And then, of course, we said before we have K, which is our constant. Here K is equal to 9 times 10 to the 10th Newton meter square coulombs. Now we are just going to plug all of the value into our Coulomb's law. So the force electric now, when we have this K is X, and this is really a function in itself K over 1, so the K goes on the top, it is K sigma K times Q times or QP, so I write down K2 to the 9th with the units multiplied by 1.6 times 10 to the minus 19. Again 1.6 times minus 9, that the charge, those, and then I'm going to divide by the square of the distance. Now, when we calculate the force, the electric force, we usually, and I will say almost always, do not put it in the negative and the positive sign. We could use that to determine whether they are attractive or repulsive force. if we put the charge in and the value comes out to be negative, that we know the attractive comes out, but positive, we know it is repulsive, but we want to know the direction and the magnitude, the direction. We can just draw and think about just be knowing whatever they are opposite charge or the same charge. So we just use absolute value of the magnitude. So then we are going to do the math now. Before we do the math, we'll note that we have our units here for newtons in the newton that we are going to need of force. So we need other units to cancel, and you can, this column is multiplied by this column, which that column square. On the top of this fraction and this columns, the fractions, so those columns are going to cancel. Then we want our meters to cancel we have meter squared up there, and this whole value, the magnitude of the distance and the unit square, so that going to be meter squared. So the meter square cancel with this meter square, then we are left with the newtons. So sound like we should be on the right track. All right, now we multiply this times this and divided by 0.3 times 10, the minus 10 squared. You have remember to square the distance, then you cancel the square, you still have to square the distance, and if you do not that, you get 8.2 times 10 to the minus 8 newtons. So that is the force that the electron feels in this direction. From the proton, and we could call the direction to the left, you could say it in the negative direction. Okay, now it is happening that we have two charges, and if the electron feel force of 8.2 times 10 minus to the left feels force, which is the equal but opposite direction, 8.2 times 10 to the minus 8 newton to the right. Okay, so we have equal opposite force working in this situation, and that's always the case when you have two charges. Case when you think relatively, this unit thing might be squarely, but basically one number times another divided by the square of